It showed how nature can offer solutions that are both efficient and Have you ever wondered how nature has inspired some of the most revolutionary technologies we use today? From the way birds soar through the skies to the microscopic strength of a spider's web, nature has been the blueprint for countless innovations. Imagine technology so ingenious that it mimics the way life itself solves complex problems. Join us as we uncover 10 groundbreaking everyday technologies inspired by nature's genius, revealing how the natural world shapes the modern one. Velcro and burrs. It's hard to imagine a world without Velcro, but its story begins in the Swiss Alps with an observant engineer and some pesky burrs. In 1941, Georges de Mestral noticed how these tiny seeds stuck to his dog's fur and his clothes during a hike. Curious, he studied them under a microscope and found a structure of tiny hooks that latched onto loops in fabric or fur. This natural mechanism became the inspiration for Velcro, a hook-and-loop fastener that revolutionized everything from clothing to space exploration. Today, Velcro is used in ways George could never have imagined. It's a staple in the fashion industry, allowing for quick adjustments and closures. It's also a hero in medicine, helping secure bandages and orthopedic devices. Even astronauts rely on Velcro in zero gravity to keep tools in place. What started as a nuisance in nature is now an essential tool for convenience and functionality. What's truly amazing is how Velcro shows the genius of biomimicry. By mimicking the simple yet effective mechanism of burrs, it transformed industries. It's a testament to the fact that nature often holds the answers to some of our most challenging design problems. Who would have thought that a hike in the woods could lead to such an invention? The next time you use Velcro, remember its origins in the wilderness. That simple burr, often dismissed as annoying, became the foundation for a technology that changed how we connect and secure things in our everyday lives. The Kingfisher and high-speed trains. The sleek design of Japan's Shinkansen, or bullet train, didn't just come from engineers, it was inspired by a bird. In the late 1980s, the train faced a noisy problem. Every time it exited a tunnel at high speeds, it created a loud tunnel boom due to air pressure changes. The solution? The Kingfisher is a bird known for its ability to dive into water without creating a splash. The team behind the train studied the bird's beak, which is shaped to minimize resistance. By redesigning the front of the train to mimic the Kingfisher's streamlined beak, they solved the noise issue and improved energy efficiency. The new design not only made the train quieter but also allowed it to travel faster while using less electricity. This innovation is a perfect example of how biomimicry can solve modern problems. Instead of forcing a solution, the engineers looked to nature, where millions of years of evolution had already perfected the design. The Kingfisher's ability to enter water seamlessly inspired a train that can cut through air just as smoothly. The next time you see a high-speed train zipping across the landscape, remember the humble Kingfisher? Its elegant dive didn't just inspire a quieter train, it showed how nature can offer solutions that are both efficient and beautiful. Shark skin and germ-free surfaces. Sharks are often thought of as terrifying predators, but their skin has inspired something that protects us: germ-resistant surfaces. Shark skin is covered with microscopic, tooth-like structures called dermal denticles. These ridges reduce drag in water, allowing sharks to move efficiently. But scientists discovered something else. These ridges prevent bacteria from clinging to the surface. This discovery led to the creation of sharklet, a surface material that mimics the texture of shark skin. It's used in hospitals where preventing bacterial growth is critical. Unlike traditional antibacterial coatings, sharklet doesn't rely on chemicals. It physically stops bacteria from latching on. This makes it a safer, more sustainable option for healthcare and hygiene. The applications of this technology extend beyond hospitals. It's being explored for use in public transport, schools, and even kitchens, where cleanliness is paramount. By studying a creature that has survived for millions of years, scientists developed a material that could reduce infections and improve sanitation worldwide. It's incredible how something as primal as shark skin can inspire modern solutions. The next time you think of sharks, consider their role in making the world a cleaner, safer place, not just as predators, but as protectors. The lotus leaf and self-cleaning surfaces. The lotus leaf, known for its beauty and symbolism in many cultures, is also a marvel of natural engineering. Its surface is covered with tiny bumps that repel water and dirt, keeping it spotless even in muddy ponds. This phenomenon, known as the lotus effect, inspired the development of self-cleaning surfaces. Scientists replicated this effect to create coatings for windows, solar panels, and even fabrics. These surfaces repel water, causing it to bead up and roll away, taking dirt with it. It's an innovation that saves time, reduces maintenance, and even extends the lifespan of materials. Imagine windows that clean themselves every time it rains, or solar panels that stay efficient without manual cleaning. The lotus effect goes beyond convenience. It reduces the need for harmful cleaning chemicals, making it an environmentally friendly solution. From skyscrapers to personal gadgets, the applications of this technology are limitless. It's a perfect example of how nature can inspire sustainability and efficiency. Next time you see rain sliding effortlessly off a surface, think of the lotus leaf. What seems like a simple natural process has inspired a technology that's transforming industries and reducing our environmental impact. Gecko feet and super adhesives. Geckos are nature's climbing champions, effortlessly scaling walls and ceilings. Their secret lies in the microscopic hair-like structures on their feet called setae, which create a weak molecular attraction known as van der Waals forces. These forces allow geckos to grip surfaces without using suction or glue, making their ability both strong and reusable. This natural mechanism inspired the creation of super adhesives that mimic gecko feet. Unlike traditional adhesives, these materials are reusable and leave no residue behind. They are used in robotics, allowing machines to climb walls and ceilings just like geckos. Even in the medical field, gecko-inspired adhesives are being developed for wound care, providing a secure yet painless alternative to stitches or staples. What makes gecko-inspired adhesives so fascinating is their potential for future innovations. From helping astronauts stick tools to the walls of spacecraft to creating reusable household items like wall hooks, the possibilities are endless. By understanding the science behind the gecko's grip, engineers are creating solutions that are both practical and eco-friendly. The next time you see a gecko defying gravity, remember that its tiny feet have sparked a revolution in adhesives. It's proof that even the smallest creatures can inspire some of the biggest breakthroughs. Spider silk and strong, lightweight materials. Spider silk is nature's ultimate multitasker. It's stronger than steel by weight, more flexible than synthetic fibers, and incredibly lightweight. Spiders use it to build webs, catch prey, and even protect their young, making it one of the most versatile materials in nature. Scientists have long been fascinated by spider silk's unique properties. By studying its molecular structure, researchers have developed synthetic versions of spider silk for various applications. These include bulletproof clothing, lightweight ropes, and even biodegradable sutures in medicine. The material's strength and flexibility make it ideal for industries ranging from defense to healthcare. What's even more exciting is how spider silk is being produced. Instead of farming spiders, researchers use bioengineering to produce silk proteins in bacteria, yeast, or even plants. This method makes it scalable and sustainable, ensuring that nature's design can benefit modern technology without harming ecosystems. Spider silk isn't just a natural marvel, it's a glimpse into the future of materials science. Whether it's protecting lives or improving sustainability, the humble spider is helping us weave a better world. Termite mounds and climate-controlled architecture. Termites, often seen as pests, are actually master architects. Their mounds, found in some of the world's hottest regions, stay cool inside even when temperatures outside soar. This is due to their ingenious natural ventilation system, which circulates air and regulates temperature without using energy. Inspired by termite mounds, architects have developed buildings with natural cooling systems. One famous example is the Eastgate Center in Zimbabwe, a shopping complex that uses passive cooling inspired by termite mound design. The building consumes less than 10% of the energy used by traditional air-conditioned structures, proving that biomimicry can be both innovative and sustainable. The termite-inspired design isn't just limited to commercial buildings, it's being applied to homes and offices, helping reduce energy consumption and carbon footprints. By learning from these tiny insects, we're creating spaces that are not only comfortable but also environmentally friendly. The next time you hear about termites, think of them as nature's green architects. Their remarkable structures are paving the way for energy-efficient designs that could reshape our built environment. Whales and wind turbine efficiency. Whales, especially humpbacks, are massive yet surprisingly agile swimmers. Their fins are equipped with unique bumps called tubercles, which help reduce drag and improve lift. This adaptation allows whales to maneuver gracefully through water despite their size. Engineers have applied this principle to wind turbines, redesigning their blades to mimic the tubercles on humpback whale fins. The result is a more efficient turbine that generates more energy, even in low wind conditions. These biomimetic blades are not only improving renewable energy production, but also reducing the environmental impact of wind farms. The whale-inspired design doesn't stop at wind turbines, it's also being explored for airplane wings, underwater vehicles, and even sports equipment like surfboards. By copying nature's efficient designs, we're finding smarter ways to interact with the elements. The next time you see a wind turbine spinning on the horizon, think of the humpback whale. Its elegant fins have inspired a cleaner, greener future for energy. Butterfly wings and color without pigments. Butterfly wings are dazzling not just because of their colors, but because of how those colors are created. Instead of using pigments, butterfly wings rely on microscopic structures that reflect and bend light, producing iridescent hues. This natural phenomenon, called structural coloration, is both vibrant and long-lasting. Inspired by butterfly wings, scientists have developed materials that mimic this structural coloration. These are used in everything from cosmetics to high-tech displays and even security features on currency. Unlike traditional dyes or pigments, these materials don't fade over time, making them more durable and environmentally friendly. The applications go beyond aesthetics. Structural coloration is being explored for energy-efficient displays, where colors are produced without backlighting. It's also being used in textiles to create fabrics that change color under different lighting conditions, opening up new possibilities in fashion and design. The brilliance of butterfly wings shows how beauty and functionality can go hand in hand. They remind us that even the smallest details in nature can inspire transformative technologies. Woodpeckers and shock-absorbing technology. Woodpeckers endure thousands of impacts daily as they peck at trees, yet they don't suffer brain injuries. This is thanks to their unique anatomy, which includes a spongy bone structure in their skull and a specialized beak that absorbs shock. Inspired by woodpeckers, engineers have developed shock-absorbing materials for helmets and protective gear. These materials mimic the bird's ability to distribute impact, providing enhanced safety for athletes, construction workers, and even military personnel. Woodpecker-inspired designs are also being used in technology. For example, they've influenced the development of shock-proof casings for delicate electronics and sensors for space exploration. By studying how these birds handle extreme forces, researchers are creating innovations that protect both people and devices. The next time you see a woodpecker at work, think of its role in advancing safety and technology. Its remarkable resilience has inspired solutions that keep us safe in some of the most challenging environments. That wraps up our exploration of 10 everyday technologies inspired by nature's brilliance. From gecko feet to butterfly wings, these innovations show how closely connected we are to the natural world. If you enjoyed this journey into biomimicry, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the wonders of nature and science with us. Have you ever looked up at the night sky and wondered how satellites make our modern world tick? From GPS navigation to weather forecasting and even connecting remote parts of the globe, satellites are the silent heroes orbiting miles above us. But how do they work, and what makes them so vital to our lives? Join us as we explore 10 simple yet fascinating facts about satellites, unraveling their mysteries and showcasing their importance in our everyday world. They defy gravity to stay in orbit. Satellites orbit Earth because they've mastered the art of balancing speed and gravity. Here's how it works. As a satellite is launched into space, it reaches incredible speeds of about 17,500 miles per hour. At this velocity, Earth's gravity pulls the satellite toward the surface, but its speed keeps it from crashing down. This creates a perfect loop, where the satellite is constantly falling toward Earth, but moving fast enough to miss it. This balance is what we call an orbit. Depending on their purpose, satellites are placed in different orbits. Low Earth orbit, for example, is perfect for satellites that need detailed imaging, like those used for mapping or weather monitoring. On the other hand, satellites in geostationary orbit match Earth's rotation, making them ideal for tasks like broadcasting TV signals. Understanding this delicate dance between speed and gravity reveals just how ingenious satellite design truly is. The rocket launch that places satellites in orbit is a marvel in itself. It's all about achieving escape velocity, the speed needed to break free of Earth's gravitational pull. Once in orbit, satellites don't need constant fuel. Their momentum and the vacuum of space keep them moving. Every satellite in orbit is a testament to the brilliance of engineering and physics, proving that humanity can reach for the stars, literally. So, the next time you check your GPS or tune into your favorite satellite channel, remember this delicate act of balancing speed and gravity. It's an extraordinary feat that has become a vital part of our everyday lives. They transform communication. Satellites revolutionized communication by bridging vast distances, making the world more connected than ever before. When you make an international phone call, watch live TV, or use the internet in a remote location, chances are a satellite is involved. These incredible machines relay signals from one part of the globe to another, bouncing them off their onboard transponders and back down to Earth. Before satellites, long-distance communication relied on undersea cables or radio waves, which were often slow or unreliable. Satellites changed the game by providing a direct link between locations, no matter how remote. Take geostationary satellites, for example. They hover over the same spot on Earth, enabling uninterrupted communication signals for live broadcasts or global internet coverage. The versatility of satellites doesn't stop there. They've become the backbone of global navigation systems like GPS, allowing your smartphone to pinpoint your location with extraordinary accuracy. Whether you're navigating a city or trekking through the wilderness, satellites are your invisible guides in the sky, ensuring you never lose your way. Think about how often you rely on satellites without even realizing it. They connect people across continents, provide internet access to the most isolated communities, and keep the world informed. Satellites are not just tools, they're the unsung heroes of modern communication. They keep an eye on Earth. Satellites are like Earth's eyes in the sky, constantly observing and gathering data about our planet. Whether it's tracking hurricanes, monitoring deforestation, or measuring sea levels, Earth observation satellites play a critical role in understanding and protecting our world. These satellites use advanced sensors and cameras to capture high-resolution images, providing scientists and governments with valuable insights. Weather satellites are among the most recognizable. They help meteorologists predict storms, map climate patterns, and even warn us of extreme weather events. Without them, accurate weather forecasting would be nearly impossible. Similarly, environmental satellites monitor changes in land use, track forest fires, and even help detect illegal mining or fishing activities. The information gathered isn't just for scientists. Farmers use satellite data to plan irrigation, conservationists monitor endangered habitats, and emergency responders rely on it for disaster management. These satellites make our lives safer and more efficient by turning data into actionable knowledge. Every image and piece of data from these satellites helps us understand our planet better. They remind us that Earth is a shared home, requiring constant care and attention. Satellites might be far away, but their impact is deeply rooted in the way we protect and cherish our environment. They've explored the universe. Satellites aren't limited to orbiting Earth. They've ventured far into the universe, unraveling mysteries of the cosmos. From the Hubble Space Telescope capturing breathtaking images of galaxies to interplanetary probes exploring distant planets, satellites are our robotic explorers. These missions expand humanity's understanding of space, answering questions we've pondered for centuries. The James Webb Space Telescope, for instance, is designed to peer into the universe's earliest moments, observing the formation of stars and galaxies. It's like a time machine, looking back billions of years. Other satellites like Voyager have traveled beyond our solar system, carrying messages from Earth in case they encounter extraterrestrial life. These space missions aren't just scientific endeavors, they inspire humanity's collective imagination. They remind us of our curiosity, our desire to explore, and our ability to create technology that reaches beyond what was once thought possible. With every satellite launched into space, we push the boundaries of what we know. They are humanity's extended hands, reaching into the vast unknown and bringing pieces of the cosmos back to us. They provide global navigation. Satellites have completely transformed the way we navigate the world. Think about it. Whether you're driving to a new city, tracking a package, or checking the best hiking trail, you're relying on satellites. The Global Positioning System, or GPS, is a network of satellites orbiting Earth that sends signals to your device. By calculating the time it takes for these signals to reach you, GPS pinpoints your exact location. This technology isn't just for maps. Airlines use GPS for safe flight paths, ships navigate vast oceans with pinpoint precision, and even farmers use it to plant crops in perfectly straight rows. It's an invisible network that makes modern life smoother and more efficient. What's fascinating is that GPS works in real time. The satellites are constantly communicating with ground stations and your device, ensuring that every move you make is tracked with incredible accuracy. Beyond GPS, there are other satellite navigation systems like Europe's Galileo and Russia's GLONASS, ensuring global coverage. Next time you find your way with just a tap on your phone, remember the satellites working tirelessly above. They're the reason we can travel, explore, and even get that late-night delivery to the right door. They bring the world together with broadcasting. Satellites play a massive role in bringing entertainment and information right to your living room. From live sports events to global news coverage, and even your favorite binge-worthy shows, satellites power it all. Communication satellites beam signals from one part of the world to another, making real-time broadcasting possible. Before satellite broadcasting, content delivery was limited to specific regions. Now, a match happening in London can be watched live in Sydney or New York. The same satellites that deliver your shows also provide critical updates during emergencies, ensuring that vital information reaches people no matter where they are. What's even more impressive is how satellites enable connectivity in remote areas. Many parts of the world that lack cable infrastructure rely on satellite TV and internet to stay connected. It's not just about entertainment. It's about bridging gaps and bringing the world closer together. Every time you switch on the TV or stream online content, there's a satellite ensuring you're connected. It's a technology that has quietly but profoundly changed how we share and consume information. They monitor Earth's climate. Climate change is one of the biggest challenges facing humanity, and satellites are at the forefront of tracking and understanding it. These high-tech instruments collect data on sea levels, ice coverage, greenhouse gases, and even deforestation rates, providing an invaluable resource for scientists and policymakers. Satellites like NASA's Aqua and the European Space Agency's Sentinel-6 monitor our planet's vital signs, giving us a clearer picture of how Earth's climate is changing. This data helps predict natural disasters, track global warming trends, and even guide conservation efforts. What makes satellites so powerful is their ability to see the big picture. From their vantage point in space, they can observe changes on a global scale, something that ground-based instruments simply can't achieve. They're also instrumental in creating climate models, helping us prepare for the future. The insights gathered by these satellites don't just stay with scientists, they inform international agreements, guide disaster response, and help us take steps toward a more sustainable future. Satellites are our planet's guardians, providing the knowledge we need to protect it. They revolutionize disaster management. When disaster strikes, satellites are often the first to respond. Whether it's a hurricane, wildfire, or earthquake, satellites provide real-time data that helps authorities plan rescue missions and allocate resources. They capture images of affected areas, track storm paths, and even detect heat signatures from wildfires. Satellites like NOAA's GOES and Copernicus emergency management satellites are specifically designed to assist in these situations. By providing up-to-date information, they enable faster responses, potentially saving countless lives. Imagine being able to predict a flood's path or pinpoint areas where help is needed most. That's the power of satellite technology. It doesn't stop there. Satellites also play a critical role in the aftermath of disasters. They help map damage, monitor recovery efforts, and ensure that resources are distributed effectively. For communities in remote areas where ground communication might be cut off, satellites become the lifeline, enabling emergency communication. In the face of adversity, satellites show their true potential, proving that technology can be a force for good, bringing hope and help when it's needed most. They help track wildlife and conserve nature. Satellites aren't just about technology, they also help protect life on Earth. Conservationists use satellite imagery to monitor wildlife habitats, track animal movements, and combat illegal activities like poaching and deforestation. This bird's-eye view allows scientists to understand ecosystems on a global scale. For example, GPS tracking collars on animals communicate with satellites, providing real-time data on migration patterns and behavior. This information helps create protected areas and plan conservation strategies. Satellites have been instrumental in tracking endangered species like elephants, sea turtles, and even migratory birds. Illegal logging and mining can also be identified through satellite images, helping authorities take action before irreversible damage occurs. Satellites like Landsat have been crucial in exposing deforestation hotspots, giving us the tools to fight environmental destruction. These technological guardians help us coexist with nature. Every pixel of data they provide is a step toward preserving the beauty and diversity of our planet for future generations. They inspire the future of space exploration. Satellites are the foundation of our dreams to explore the cosmos. By studying other planets, mapping distant stars, and even testing technologies for human space travel, satellites are paving the way for the next generation of exploration. Missions like the Hubble Space Telescope and the upcoming James Webb Telescope showcase how satellites can unlock the secrets of the universe. They allow us to study black holes, identify exoplanets, and even search for signs of life in far-off galaxies. Satellites also serve as stepping stones for ambitious projects like colonizing Mars or returning to the Moon. They test communication systems, monitor potential landing sites, and ensure we understand the challenges of space travel before humans take the leap. With every launch, satellites fuel our imagination and remind us of humanity's potential. They're not just tools, they're symbols of what we can achieve when we look beyond the horizon and dare to dream big. And there you have it, 10 simple but incredible facts about how satellites shape our world and beyond. From revolutionizing communication to inspiring space exploration, satellites truly are wonders of modern science. If you love diving into these amazing facts, don't forget to like, share, and subscribe to InnoVision Tech. Hit the bell icon to stay tuned for more thrilling explorations of the wonders all around us. See you next time.
Ever wondered what mysteries lie beyond the blue horizon of Neptune? From its supersonic winds to its hidden ocean of liquid water, this distant giant planet is full of astonishing surprises. Neptune, the eighth planet from the Sun, remains one of the most enigmatic members of our solar system. What makes it so unique, and why does it capture our imagination? Join us for an incredible journey into the heart of Neptune's wonders, where science meets the extraordinary in a world of blue. Neptune is a windy wonderland. Neptune is a planet of extremes, and its winds are no exception. This gas giant holds the title for the fastest winds in the solar system, with speeds reaching up to 1,200 miles per hour. That's nearly 5 times faster than the strongest hurricanes on Earth. These incredible winds create a dynamic and chaotic atmosphere, with giant storms and dark spots moving across the planet's surface. The planet's winds are fueled by Neptune's internal heat, which radiates more energy than it receives from the Sun. This heat drives massive convection currents, creating powerful jet streams and vortices that rage across the atmosphere. These winds give Neptune its ever-changing weather patterns, despite its frigid distance from the Sun. One of the most famous weather features on Neptune was the Great Dark Spot, a storm system the size of Earth. Discovered by the Voyager 2 spacecraft in 1989, this giant storm vanished just a few years later, showcasing the dynamic nature of Neptune's atmosphere. Scientists are still studying what makes Neptune's winds so extreme. The planet's unique combination of internal heat, atmospheric composition, and rapid rotation all play a role, but the exact mechanisms remain a mystery. The winds of Neptune are a testament to the raw power of planetary weather, offering a glimpse into a world where nature reigns supreme. The deep blue mystery of Neptune's color. Neptune's striking blue color is one of its most defining features, but it's not just a simple reflection of the sky. This rich azure hue comes from methane in the planet's atmosphere, which absorbs red light from the sun and reflects blue light back into space. However, methane alone doesn't fully explain Neptune's intense coloration. Scientists believe that there are other, unknown components in the atmosphere that enhance the blue tone. These mystery molecules have yet to be identified, making Neptune's appearance as much a scientific puzzle as it is a visual marvel. Neptune's vivid blue sets it apart from its neighbor Uranus, which also contains methane but appears a paler shade of blue-green. The subtle differences in atmospheric composition between these two planets highlight just how unique Neptune truly is. The planet's color isn't just an aesthetic feature, it provides valuable clues about the composition and chemistry of its atmosphere. By studying Neptune's blue, scientists gain insights into the processes at work on this distant world, and even on exoplanets that share similar characteristics. Neptune's mesmerizing blue reminds us of the beauty and complexity of our solar system, where even the color of a planet holds untold secrets. The discovery of Neptune was a mathematical marvel. Neptune's discovery in 1846 wasn't a stroke of luck, it was a triumph of mathematics and astronomy. Scientists noticed that the orbit of Uranus wasn't following predictions, suggesting the gravitational pull of an unseen planet. Using calculations, French mathematician Urbain Le Verrier pinpointed Neptune's position without ever looking through a telescope. When German astronomer Johann Galle aimed his telescope at the predicted spot, Neptune was there, just as Le Verrier had calculated. This marked the first time a planet was discovered through mathematical prediction, rather than direct observation, a breakthrough that changed the course of astronomy. Interestingly, English mathematician John Couch Adams had also made similar calculations around the same time, leading to a controversy over who deserved credit for Neptune's discovery. In the end, both Le Verrier and Adams are recognized for their contributions. Neptune's discovery also underscored the power of Newton's laws of motion and universal gravitation, which formed the basis of the calculations. This event cemented the idea that mathematical models could predict the existence of celestial objects, a concept that continues to guide modern astronomy. The discovery of Neptune stands as a testament to human ingenuity, showing how the mind can uncover worlds hidden from the eye. Neptune's rings are thin and wispy. Neptune is adorned with a set of faint, thin rings that add to its otherworldly charm. These rings, made of dust and ice particles, are far more delicate and less prominent than those of Saturn. There are 5 main rings: Galle, Le Verrier, Lassell, Arago, and Adams, each named after notable scientists who contributed to our understanding of the planet. What makes Neptune's rings unique is their clumpy and uneven distribution, a phenomenon scientists are still trying to understand. Some parts of the rings appear brighter and denser, forming arcs rather than smooth, continuous bands. These arcs are thought to be stabilized by the gravitational pull of Neptune's moons, particularly Galatea. The rings were first detected in the mid-1980s through ground-based observations and were later confirmed by the Voyager 2 spacecraft. Voyager's flyby provided detailed images of the rings, revealing their complex structure and composition. Despite their faintness, Neptune's rings hold valuable information about the planet's history and the processes that shaped its outer regions. By studying the rings, scientists hope to uncover clues about the formation of the outer solar system and the interactions between moons and planetary rings. Neptune's rings may not be as famous as Saturn's, but they are a delicate reminder of the intricate beauty found throughout the cosmos. Neptune is an ice giant with a hidden ocean. Neptune belongs to a category of planets known as ice giants, which are distinct from gas giants like Jupiter and Saturn. Beneath its thick atmosphere lies a mantle of water, ammonia, and methane ice, creating an interior vastly different from the gas giants. This icy composition gives Neptune its classification, but it also raises intriguing possibilities. Scientists believe that under the icy mantle lies a vast ocean of superheated, high-pressure water. This ocean, kept in a liquid state by extreme pressure, could potentially harbor exotic forms of life or unusual chemical processes. Neptune's core is a rocky mix of silicates and metals, surrounded by this mysterious ocean. The transition from the icy mantle to the core is gradual, creating a layered structure that adds to the planet's complexity. The pressure and temperature in Neptune's interior are so extreme that methane molecules could break apart, forming diamonds. These diamonds might sink to the core, creating a glittering layer of solid carbon, a phenomenon often referred to as the diamond rain. Neptune's status as an ice giant with a hidden ocean sets it apart as a planet full of surprises, challenging our understanding of what a world can be. Neptune's moons are a diverse family. Neptune is home to 14 known moons, each with its own unique characteristics. The largest and most famous is Triton, a fascinating moon with a retrograde orbit, meaning it orbits Neptune in the opposite direction of the planet's rotation. This unusual motion suggests that Triton was likely captured from the Kuiper Belt, a region of icy objects beyond Neptune. Triton is a world of wonders, featuring geysers that spew nitrogen gas, a thin atmosphere, and a surface covered in frozen nitrogen and methane. Its geologically active surface makes it one of the most intriguing moons in the solar system, and a prime candidate for future exploration. In contrast to Triton's icy splendor, Neptune's smaller moons are less dynamic but no less interesting. Proteus, the second largest moon, is oddly shaped and heavily cratered, suggesting it has remained relatively unchanged for billions of years. Nereid, another notable moon, has one of the most eccentric orbits of any moon, swinging dramatically closer and farther from Neptune. These moons offer a glimpse into the diverse processes that shape planetary systems. Some moons are likely remnants of Neptune's original satellite system, while others, like Triton, are later additions. Studying them helps scientists understand how moons form and evolve over time. Neptune's moons are a microcosm of the solar system's complexity, each contributing to the rich tapestry of this distant planet. Neptune's magnetic field is misaligned and tilted. Neptune's magnetic field is unlike any other in the solar system. It's both off-center and tilted at a staggering 47 degrees relative to the planet's rotational axis. This means that Neptune's magnetic field is constantly shifting, creating a wildly dynamic magnetosphere. The magnetic field is generated by electric currents within the planet's icy mantle, rather than in a metallic core as on Earth. This difference in origin contributes to its unusual properties, including its irregular shape and strength. In some regions, Neptune's magnetic field is up to 10 times stronger than in others. This chaotic magnetic field produces spectacular auroras, much like the northern and southern lights on Earth. However, Neptune's auroras are more scattered and less structured, appearing as patches of glowing light near the poles. The planet's unique magnetosphere also interacts with the solar wind in ways that are still not fully understood. Voyager 2 provided the first glimpses of Neptune's magnetic behavior, but many questions remain about how it affects the planet and its surrounding space environment. Neptune's magnetic field adds another layer of intrigue to this distant world, highlighting the diverse ways planets generate and sustain magnetic forces. Neptune's year lasts 165 Earth years. A year on Neptune is an extraordinary 165 Earth years long, meaning it takes nearly 2 centuries to complete one orbit around the Sun. Since its discovery in 1846, Neptune has completed just one full orbit, which occurred in 2011. This lengthy year is due to Neptune's vast distance from the Sun, about 30 times farther than Earth. At this distance, the Sun appears much smaller in Neptune's sky, providing only a fraction of the light and warmth that reaches our planet. Despite its slow orbit, Neptune rotates rapidly on its axis, completing a day in just 16 hours. This rapid spin, combined with its elliptical orbit, creates fascinating seasonal variations. Each of Neptune's 4 seasons lasts more than 40 Earth years, resulting in gradual but significant changes in atmospheric activity. Understanding Neptune's lengthy year and slow seasonal shifts provides valuable insights into the dynamics of planetary orbits and climate systems. The planet's orbit also places it in a region of the solar system that offers clues about the formation of outer planets and the migration of celestial bodies. Neptune's epic year serves as a reminder of the vast scales of time and distance that define the outer reaches of the solar system. Neptune was the last stop for Voyager 2. In 1989, NASA's Voyager 2 spacecraft became the first, and so far only probe to visit Neptune. This historic flyby provided humanity's closest look at the distant planet, revealing breathtaking details about its atmosphere, moons, and rings. Voyager 2 captured stunning images of Neptune's vibrant blue clouds, powerful storms, and faint rings, transforming our understanding of the planet. It also made groundbreaking discoveries, such as the presence of the Great Dark Spot, the dynamic weather patterns, and Triton's geysers. The spacecraft's instruments measured Neptune's magnetic field, confirming its tilted and off-center configuration. Voyager 2 also provided data on the planet's temperature, wind speeds, and atmospheric composition, laying the foundation for future studies of ice giants. Voyager 2's flyby lasted only a few hours, but its legacy endures. The mission's data continues to inform scientific research and inspire new questions about Neptune and its role in the solar system. The encounter with Neptune marked the end of Voyager 2's planetary tour, but the spacecraft remains a symbol of humanity's quest for knowledge, now traveling through interstellar space as a messenger of discovery. Neptune may hold clues to the formation of exoplanets. Neptune's status as an ice giant makes it a valuable analog for studying exoplanets, planets beyond our solar system. Many of the exoplanets discovered so far are Neptune-like in size and composition, falling into a category known as mini-Neptunes or sub-Neptunes. By studying Neptune, scientists can better understand the atmospheric processes, magnetic fields, and interior structures of these distant worlds. Neptune's dynamic weather, deep blue hue, and icy mantle offer a template for modeling the conditions on similar exoplanets. One of the most intriguing aspects of Neptune-like exoplanets is their potential habitability. While Neptune itself is inhospitable, its characteristics help researchers identify which exoplanets might have liquid water, stable atmospheres, or conditions suitable for life. Future missions to study Neptune up close, such as orbiters or atmospheric probes, could provide critical data for interpreting observations of exoplanets. These missions would also deepen our understanding of how planets like Neptune form and evolve in different stellar systems. Neptune's connection to exoplanet research highlights its importance not just as a member of our solar system, but as a key to unlocking the mysteries of the universe. Neptune is a planet of mysteries, extremes, and beauty, offering a glimpse into the farthest reaches of our solar system. From its supersonic winds to its hidden ocean, Neptune continues to captivate scientists and dreamers alike. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the wonders of the universe with us.